All right, you are welcome again. Today, we want to talk about how to solve ordinary differential equations using Laplace transform. Very simple. Okay? I just want you to pay attention. Let's see how to solve this step by step. Okay? Now, let's take a look at this problem. We are asked to solve the differential equation using Laplace transform. Y prime prime plus 2y prime minus 3y is equal to t, subject to, or the initial value is y of 0 is equal to 2 and y prime of 0 is equal to 1. Okay, please pay attention. Let's take a journey and see how to solve this problem. Okay, now I want you to pay attention to something. This equation that we are given to solve is the same thing as d squared y all over dt squared plus 2 dy all over dt minus 3y equal to t. Okay, it's still the same, right? Good. Now let's go. We are asked to solve this ordinary differential equation using Laplace transform. So we are going to take the Laplace transform of both sides. Okay? We are going to take the Laplace transform of both sides. Now, taking the Laplace transform of both sides, it requires that we take their individual Laplace transform. Okay, so taking their individual Laplace transform, we are going to see that we have the Laplace transform of y prime prime plus the Laplace transform of 2y prime minus the Laplace transform of 3y is equal to the Laplace transform of t. Okay, yes. Now let's go. By definition, the Laplace transform of the first and the second derivatives are given as. The first one, the Laplace transform of y prime, is given as s, the Laplace transform of y minus y of 0. Let's call this equation 2. Okay? Yes. Again, the Laplace transform of y prime prime, that is, the Laplace transform of second derivative, is given as s squared, the Laplace transform of y, minus s y of 0 minus y prime of 0. Hello? Yes. Let's call this equation 3. Now, looking at this equation 1, equation 2, equation 3, we are going to substitute these values of equation 2 and 3 into equation 1. Okay? Yes. Where we have the Laplace transform of y prime prime. In this equation 3, we substitute it inside equation 1. And then where we say the Laplace transform of y prime in equation 2, we substitute it into equation 1. Okay? Now, doing so, we are going to see that we have x squared, the Laplace transform of y, minus x y of 0 minus y prime of 0 plus, in this place where we have the Laplace transform of 2y prime, we bring 2 out, right? And then we put it in bracket now. S Laplace transform of y minus y of 0, close the bracket, minus 3, the Laplace transform of y, is equal to the Laplace transform of t. Okay? Now, we are given initial value, right? Initial value to be y of 0 is equal to 2 and y prime of 0 is equal to 1, right? Yes, in this place, we can see clearly that we have y of 0 and y prime of 0. So, in place of y of 0 and y prime of 0, we are going to replace, or we are going to write 2 and 1 respectively. Okay? Now, let's go. In this place, we have s squared, the Laplace transform of y, minus x y of 0. Y of 0 is 2. So we say s open bracket 2 minus y prime of 0 is 1. We say minus 1 plus 2s, the Laplace transform of y. So, in this case, we are using 2 to open this small bracket, okay? So here we have 2s, Laplace transform of y, minus 2. Here we have y of 0, and y of 0 is 2. So here we have minus 2 open bracket, 2. Then minus 3, Laplace transform of y, equal to the Laplace transform of t. Is that clear? Now, let's go. In this place, let's bring together all the terms that are having the Laplace transform of y. Okay, let's bring them together. And then other things, let's take it to the other side. So when we bring them together, we see that we have s squared, the Laplace transform of y, plus 2s, Laplace transform of y, minus 3, Laplace transform of y, is equal to, we have Laplace transform of t in the other side, and then taking minus 2s to the other side, we have plus 2s, and then here we have minus 1, and then minus 4, because when you say 2 times 2, it's going to give you minus 4, right? So when you say minus 1, minus 4, it is minus 5. Now, crossing to the other side is going to give us plus 5. Is that clear? Yes. Now, let's go. In this place where we have the Laplace transform of y, okay, in the first term, it has a coefficient s squared. The second term has coefficient 2s. The third term have a coefficient minus 3. So let's factor out this Laplace transform of y, okay, in these first 3 terms where it appears. So when we factor it out, we are going to have the coefficients remaining, which are s squared plus 2s minus 3. Okay, yes, it's equal to, in the right hand side here, where we say the Laplace transform of t. What is the Laplace transform of t? It is 1 all over s squared. Okay? Yes. Then we have plus 2s plus 5. Is that clear? Yes. Now, let's combine these right-hand sides together. Let's combine it. So when you combine it, we are going to have 1 plus 2s cubed plus 5s squared all over s squared. Okay? Yes. Now here in the left-hand side, we have the Laplace transform of y, and then the coefficient s squared plus 2s minus 3 is equal to, in the right-hand side, we have 1 plus 2s cubed plus 5s squared all over s squared. Now, let's make Laplace transform of y the subject by dividing both sides by the coefficient, okay, or multiplying both sides by the inverse of the coefficient, which is going to give us 1 all over s squared plus 2s minus 3. Okay, either we divide both sides by this coefficient, or we multiply both sides by the inverse of this coefficient, so that the Laplace transform of y will stand alone. Okay, so when we do so, we are going to see that the Laplace transform of y is equal to, we have 1 plus 2s cubed plus 5s squared all over s squared multiplied by 1 all over s squared plus 2s minus 3. Okay, yes. Now, let's combine this again. So when you combine this together, we are going to have the Laplace transform of y is equal to 1 plus 2s cubed plus 5s squared all over s squared, open bracket, s plus 3, in bracket, s minus 1, in bracket. That is, this place we have s squared plus 2s minus 3. When you factorize this is the 2 factors we are going to obtain. Okay, yes. Now, in this case, now we have the Laplace transform of y is equal to 1 plus 2s cubed plus 5s squared all over s squared, s plus 3 in bracket, s minus 1 in bracket. We are going to apply the partial fraction decomposition to break this down. Okay, then we apply the Laplace inverse. Okay, now applying partial fraction decomposition, we are going to see that we have the Laplace transform of y is equal to 1 plus 2s cubed plus 5s squared all over s squared. s plus 3 in bracket, s minus 1 in bracket is equal to, we're going to have as plus b all over s squared plus c all over s plus 3 plus d all over s minus 1. Okay, so we write it this way. Please, if I'm not conversant with this partial fraction decomposition, we have lessons already. Okay, please do well to go through them. Okay, now let's go. In this place where we have this, the next step we take is we multiply through by the denominator of the left hand side. Okay, good. That is, we multiply through by s squared open bracket s plus 3 close bracket s minus 1 in bracket. So when we multiply through, this is what we are going to have. We are going to have 1 plus 2s cubed plus 5s squared is equal to as plus b in bracket s plus 3 in bracket s minus 1 in bracket plus c s minus 1 in bracket s squared plus d s plus 3 in bracket s squared. Okay, yes, so this is what we have. Now what we do is, these factors, we equate each and every one of them equal to 0 and then substitute in this equation 4, then find the value for a, b, c and d. So the first one, let's set the first factor s minus 1 to 0. So we'll say s minus 1 equal to 0. That is, we are saying that s is equal to 1. So in this equation 4, anywhere we see s, we can write 1. Okay, so when we do so, we are going to see that d is equal to 2. Okay, yes, again we set the second factor equal to 0. Second factor, we have s plus 3. So when we set it equal to 0, that is to say that s is equal to minus 3. So in this equation 4, anywhere we see s, we write minus 3. So when we do so, we are going to see that c is equal to minus 2 all over 9. Hello, c is equal to minus 2 all over 9. Now for the last time, we set s squared equal to 0. So when we set s squared equal to 0, we see that s is equal to 0, right? Yes, anywhere we see s in this equation 4, we write 0. What are we going to have? We are going to see that b is equal to minus 1 all over 3. b is equal to what? Minus 1 all over 3. Now look at this very carefully. You know, we are looking for the value for a, b, c and d. So substituting or equating these factors to 0, we are able to find the value for b, the value for c and the value for d, remaining the value for what? For a. So what do? Let's go back to this equation 4. In this equation 4, we have 1 plus 2s cubed plus 5s squared is equal to as plus b in bracket s plus 3 in bracket s minus 1 in bracket plus c s minus 1 in bracket s squared plus d s plus 3 in bracket s squared. Okay, this is equation 4. So what we do is, we open the brackets and then collect like terms. So when we collect like terms, we factor out s squared, s and s cubed. Okay, so we'll do so. This is what we are going to have. When we multiply all these brackets and then collect like terms, factor out s cubed, s squared and s. This is what we are going to have. We are going to see that 1 plus 2s cubed plus 5s squared is equal to a plus b plus d in bracket s cubed plus 2a plus b minus c plus d in bracket s squared plus 2b minus 3a in bracket s minus 3b. This is what we have. Okay, yes. Now look at this equation in the right hand side and equation in the left hand side. Let's compare their coefficients. Okay, let's compare their what? Their coefficients. So the coefficient of s cubed in the right hand side is equal to the coefficient of x cubed in the left hand side. The coefficient of x squared in the right hand side is equal to the coefficient of x squared in the left hand side. Likewise for s. Okay, now let's go. Comparing them, we see that the coefficient of s cubed in the right hand side, we are having a plus c plus d. Then in the left hand side is equal to what? 2. Good. And then the coefficient of s squared in the right hand side, we have 2a plus b minus c plus d is equal to the coefficient of x squared in the left, which is equal to what? 5. Again, the coefficient of s in the right hand side, where we have 2b minus 3a, is equal to 0 because there is no s in the left hand side. Okay, good. Now let's go again. The last one, the coefficient of s raised to power 0 in the right hand side, we have minus 3b, is equal to the coefficient of s raised to power 0 in the left hand side, which is 1. Okay, so here we say that minus 3b is equal to 1. So what do we have here? So making b the subject, we see that b is equal to minus 1 all over 3. Okay, using comparing coefficient, we also obtain the same value for b as what we obtained while we set s squared equal to 0. Is that clear? Yes, in this place we have equation a, equation b, and equation c. So we can use any of the equations to find a that we are looking for, all right, because we have found b, c, and d. So okay, let's just, without wasting much time, let's use the simplest equation here, which is equation c, where we have 2b minus 3a is equal to 0, where we already know the value for b, and value for b is minus 1 all over 3. Okay, so when we substitute here, we are going to say that 2 open bracket minus 1 all over 3 close bracket minus 3a is equal to 0. So multiply this and take it to the other side. We are going to see that minus 3a is equal to 2 all over 3. All right, yes, make a the subject. We see that a is equal to minus 2 all over 9. A is equal to minus 2 all over 9. All right, yes. Now look at this. We have found the value for a, b, c, and d, and they are: a is equal to minus 2 all over 9, b is equal to minus 1 all over 3, c is equal to minus 2 all over 9, and d is equal to 2. Okay, yes. Now let's go again. In this place where we'll say the Laplace transform of y is equal to 1 plus 2s cubed plus 5s squared all over s squared, s plus 3 in bracket, s minus 1 in bracket, is equal to as plus b all over s squared plus c all over s plus 3 in bracket plus d all over s minus 1 in bracket. Okay, yes. Now in this place, we have found the value for a, b, c, and d. Let's substitute. So substitute, we are going to have the Laplace transform of y is equal to, in place of a now we have minus 2 all over 9s minus, we have 1 all over 3, that is for b, all over s squared plus, then for c we have minus 2 all over 9 all over s plus 3, then plus, for d we have 2 all over s minus 1. Okay, now let's go. Let's simplify this. Please pay attention to the steps that we take to simplify this. So the first one, where we have minus 2 all over 9s, right, minus 1 all over 3 all over s squared. We can separate this, or we can split this into 2. So when we split this into 2, we are going to have minus 2s all over 9 all over s squared minus 1 all over 3 all over s squared. Is that true? Yes. And then we have plus. In this place where we have minus 2 all over 9 all over s plus 3 is the same as saying minus 2 all over 9 divided by s plus 3. Then we have plus 2 all over s minus 1. All right? Yes. Now let's go. In this place where we have minus 2s all over 9 all over s squared, it's still the same thing as saying minus 2s all over 9 times 1 all over s squared. Hello. Yes. When we perform inversion, all right, this is what we're going to have. Then we have minus. We have 1 all over 3. Then we do the same thing. We say times 1 all over s squared. Then plus. We have minus 2 all over 9 times 1 all over s plus 3. Then we have plus 2 all over s minus 1. Is that clear? Yes. Now let's go. Here we have the Laplace transform of y is equal to, when we multiply this, the first term, s, we cancel s. Okay? So we are going to have minus 2 all over 9s. That is for the first term. Then minus, the next one we are going to have 1 all over 3s squared. Okay? Yes. Then we have minus 2 all over 9, open bracket, s plus 3. Alright, yes. Plus, the next one we have 2 all over s minus 1. Okay, so this is the value for the Laplace transform of y. But we are looking for y. That is the solution, okay? The solution to the ordinary differential equation. So we are looking for y. So what do? We remove this Laplace of y by taking the Laplace inverse of this y. So we are going to take the Laplace transform inverse of both sides, and then their individual Laplace transform. Okay, now let's go. That means taking the Laplace inverse of both sides, we are going to see the Laplace inverse of y is equal to the Laplace inverse of minus 2 all over 9s minus the Laplace inverse of 1 all over 3s squared minus the Laplace inverse of 2 all over 9, open bracket, s plus 3, plus the Laplace inverse of 2 all over s minus 1. Okay, now in this Laplace inverse, all these places we have constant or coefficient. Let's factor them out. In the first one, we bring out minus 2 all over 9. So when we bring it out, we have Laplace inverse of 1 all over s. Then minus. In the second one, we bring out minus 1 all over 3 out. So we are going to have the Laplace inverse of 1 all over s squared. Then the third one, we bring out minus 2 all over 9 out. So we are going to have 1 all over s plus 3. And then the last one, we bring out 2 outside. We are going to have the Laplace inverse of 1 all over s minus 1. Okay? Yes. Now let's take their Laplace inverse properly. So for the first term, where we see the Laplace inverse of 1 all over s, Laplace inverse of 1 all over s is going to give us 1. Hello? It's going to give us what? 1. Good. Now the next one, we have minus 1 all over 3. The Laplace inverse of 1 all over s squared is t. Hello? Is what? Is t. Now let's go again. The third term, the Laplace inverse of 1 all over s plus 3 is going to give us e raised to the power of minus 3t. Hello? E raised to the power of minus 3t. And then the last one, we have 2 multiplied by e raised to the power of t. Okay? Yes. Now let's multiply and then rearrange. So when we multiply, we see that y is equal to, we have 2 e raised to the power of t minus t all over 3 minus 2e raised to the power of minus 3t all over 9 minus 2 all over 9. Hello? Yes. So therefore, this is the solution to the ordinary differential equation that we are given to solve. We say that y is equal to 2e raised to the power of t minus t all over 3 minus 2e raised to the power of minus 3t all over 9 minus 2 all over 9. All right? Yes. Thank you very much. Please, I want you to pay attention. Watch this video very carefully and very attentively. All right? It's very simple. You can drop your question if there is any confusion anywhere. All right? Yes. Thank you for watching. Please, if you are new, I want you to like our video, subscribe, share, and stay blessed.